today we'll be doing IUPAC naming for the remaining two, which is alkene and alkyne. So we'll start with alkene. Let's say, for example, we have this structure C2, 3 double bond. Let me keep it simple for now. So we can see, to identify an alkene, you have to see a double bond somewhere in your structure, and we see one. So just for a reminder or recap, the structure that we'll use when naming is position of the side chain in the side chain name, then the prefix position of the longest chain, then suffix. Then in our case, the first step that you do, you identify the longest chain. So if we were to count, you'll see that the longest chain is this one: 1, 2, 3, 4, 5. Let's circle that. Then another thing that we do is to number sequentially from right to left and in reverse, right? 1, 2, 3, 4, 5, and do it in reverse. I told you about the order of precedence, right? You first identify a homologous series. If it's not there, you identify for alkene or alkyne. If it's not there, you look for a halogen. If it's not there, then you resort to a side chain. Then in our case, we can see that we have a double bond here, right? We have alkene. Then we just stop there. Then another thing, now we have to choose the order of numbering. Are we choosing the forward or the reverse? So in our case, we have to resort to the smallest number every time, right? And if you look at the forward process, the smallest number is 3. But in the reverse order, the smallest number is 3. Then that means that we'll resort to the reverse order. Then we can name. For now, we'll ignore this part because we don't have any side chain, but we can look for our prefix. How many carbons do we have? We have 5, right? So we have 5 carbons. So what's 5? That's pent. Then we're looking for the position. What's the position for alkene, the double bond? So you can see here there's 3 and 2, right? You always resort to the smallest number between that. So our smallest number will be 2. Then the position at which the double bond starts, it's at 2, and it's going to be 2. Then what's the suffix of alkene? It's in the name. It's going to be ENE. Let's do the second one, where we have a side chain and all that. Yes, the first thing that we do is to identify the longest chain. It will be 1, 2, 3, 4, 5. So that's our longest chain. And we circle the longest chain. Then everything outside of the longest chain, we consider it as a side chain. Then we're done. We do our numbering system on the longest chain, so it's 1, 2, 3, 4, 5, and also in reverse order. 1, 2, 3, 4, 5. So which order we're going to choose between the forward and the reverse? We check for the smallest number, right? So in the forward order, the smallest number is 3. Then in the reverse order, the smallest number is 2. Then we always resort to the smallest one, right? It's 2. The smallest one is 2. Then we can erase that part, or we can disregard the forward process. Then what's next is the order of precedence, right? I said you check for a homologous series in terms of precedence, right? That would be a top student. But if the top student is not there, you check for alkene or alkyne. Then we can see that we have alkene here, E and E. Then another thing, we're done with that. Then we don't have to focus on the side chain because we have the best student in the current process, right? Then we can try naming. Our naming convention is position, side chain, prefix, position of the longest chain, then suffix. Nice. Then let's check on our side chain. It's in position what? You can see it's in position 4. Then we go and write 4 there. Then what's the name of our side chain? So if it's 1 carbon, it's meth. But I said for side chain, you add the Y at the end. Then how many carbons do we have on the longest chain? You see that we have 5, so it's pent. Then what's the smallest position between the double bond? You see that it's 2. Then you write position 2 for the longest chain. Then the suffix is N. Yeah. However pronounce that E-N-E. So we'll have 4 methyl pent 2 in. So you see, in order of precedence, if we have a side chain and an alkene, you'll choose alkene as your first student. If you don't understand what I'm talking about right now, it's in the previous video, right? I spoke about order of precedence, but I'll explain further if you need any clarification on that. Then the next thing we can do is alkyne, right? Here we know that the suffix is Y-N-E. Then let's do one example. Say we have 1, 2, 3, triple bond. So the first thing that we do, that's our normal rule. We identify the longest chain. We check there. So it's 1, 2, 3, 4, 5. We're done. We can circle the longest chain. Then we do our numbering system in the forward order. So it's 1, 2, 3, 4, 5. So do it in reverse order. 1, 2, 3, 4, 5. Then we always resort to the smallest number. So you'll see that the smallest is 2. Then we can regard the forward process. Then we forget about this one. So this is the position of an alkyne, right? So let's try name. We know our naming convention. It's position, side chain, not suffix, prefix, position, suffix. For now, we don't have this part. We'll ignore that. Then what's our prefix? We count the number of C atoms in the longest chain. So it's 5. Then 5 is pent. Then what's the position of our alkyne or our functional group? You see it's alkyne and it's in position 2, smallest number. Then what's our suffix? Y, N, E. 1, number 2, 1, 2, 3. Let me just add 1 there. Yeah, we can use this one as our example. The first thing that we do is to identify the longest chain, right? Count 1, 2, 3, 4, 5, 6. Then we can circle that, right, as our longest chain. Then everything outside of that is going to be our side chain. Then let's do the numbering. So it's 1, 2, 3, 4, 5, 6. That's the forward order. The reverse order is going to be 1, 2, 3, 4, 5, 6. Then let's go and choose our order of precedence, right? Before we choose which order are we going to choose in terms of numbering. And if you can check, we have a side chain and a different hydrocarbon, which is alkyne, right? So in terms of order of precedence, what do we choose? What comes first before side chain and alkene? Then you'll see that if there's no homologous series, we forget about that. Then we check for alkene or alkyne, which is this one, right? So that's the order that we are going to choose. So when choosing the numbering, we'll choose the numbering based on that, right? So let's check the forward order. The number between the triple bond, you'll see that it's 4 and 5. In the reverse order, it's between 2 and 3. Then we choose the smallest number between that. So the order that we are going to choose is the reverse order. Then we can check our naming convention. So it says position, side chain, prefix, position, suffix. Okay, then what's the position of the side chain? It's in position 4. What's the name of the side chain? If we have 2 carbons, then we know that it's earth. Then because it's a side chain, at the end we write YL. Then the prefix, how many carbons do we have in the longest chain? It's in the number 16. So we have 6. So 6 is hex. Then the position of our hydrocarbon alkene, we know it's in position 3 and 2. Then we choose the smallest number there, 2. Then the suffix is Y and E. So it's going to be 2 ethyl hex 2 ine or YNE. We can just continue and just try and tackle the rest so that I don't have to do a lot of videos and all that. Another thing which you have to know is what you call alcohol, right? Then the general formula of alcohol is CnH2n plus 1 OH. The functional group for that is going to be hydroxyl group. Then the suffix is going to be ol, right? So how do we identify one? So on a C atom, you see that we'll have an OH, right? This is how you identify one. If you see something like that, that's alcohol. For alcohol, let's say we have 1. As I do this, I'll introduce other concepts, right? So for the sake of understanding, this is what we call a primary alcohol. So a primary alcohol is like that. OH. So if you wanted to define a primary alcohol, I can explain it to you, then you'll find a way to define it, right? So you see the C atom bonded to OH, it's bonded to 1 C atom, right? It's that. That's a primary alcohol. Then you see for secondary alcohol, the C atom bonded to OH is bonded to 2 carbons, or it's in between 2 carbons and all that. Then for now, let's try and name this one. So the first thing we do is to identify the longest chain, then number in forward and in reverse order. So now that we have a homologous series, so an alcohol, then we can resort to that. That's our best student. So when choosing a numbering system, it will be based on that, right? Or based on where the OH is bonded. So if we were to focus on the forward numbering system, you'd see that the OH is bonded on the 3rd carbon. But if you were to choose the reverse order, it's on the 1st carbon. Then which numbering system do we choose? We always choose the one with the smallest number. Then we can name that. How many carbons do we have? We have 3, right? So 3 is prop, or propan, then it's in position what? It's in position 1. For now, just write the position, right? Because just in case it's in a different position, then you'll see why this is useful. So it's going to be propan 1, then the suffix of alcohol is old. For now, we don't have any side chain, so we won't include that. So this is a primary alcohol, right? The C atom bonded to the OH is only bonded to one C atom on the other side. Would be in this format: 1, 2, 3, OH. Yes, this one is a good example. So the first thing every time that you do is to identify the longest chain. That's the longest chain. Then we number in forward. So 1, 2, 3, 4. Also in reverse: 1, 2, 3, 4. Then you can see that our functional group, or the homologous series, which is alcohol, is in position 3 in the reverse order, and in position 2 in the forward order. So we always choose the smallest number, right? So we're going to choose that one. Then we can disregard the reverse order. When naming this, we don't have a side chain, so there's no side chain outside of the longest chain. So how many carbons do we have? We have 4, and 4 it's butan. Then it's in position 2, the OH. Then the suffix of alcohol is OL. So this is a secondary alcohol. Why? Because the OH the C atom bonded to the OH is in between 2 carbons. You can see. So it's in between 2 carbons. Then let's do the last one. So here we have a tertiary alcohol. Then for tertiary alcohol, it's in this format. So you can see we're dealing with the homologous series. So the numbering system, or our system that we are going to use, will favor that. So we identify the longest chain. We number from right to left to right: 1, 2, 3, and also in reverse order: 1, 2, 3. Then you can see they're both for the forward and the reverse reaction. The OH, the C atom bonded to the OH, is in position 2 and 2. So any order that you choose there will be fine. So I'll stick to the forward order. Then you can see that in this example we have a side chain, right? Side chain, and it's outside of our longest chain. So we'll follow that standard naming process. So it's position, side chain, prefix, position, suffix. Then what's the position of the side chain? It's in position 2. What's the name of the side chain? It's 1 carbon, so it's meth. Just because it's a side chain, we'll say YL, methyl. How many carbons do you have on the longest chain? It's 3, so it's propan. Then the position at which the OH is at on the C atom is position 2, so we'll say 2. Then what's the suffix of alcohol? Is ol. So you can see that it's 2-methyl propan 2-ol. Let me try and explain what's a tertiary alcohol. So a tertiary alcohol, you can see that the C atoms that are bonded to the C atom bonded to the OH are 3, right? Then that's how we explain a tertiary alcohol. I don't know how to define this in a proper way, but you just have to go and look for a proper definition. But that's how we identify a tertiary alcohol. And you'll see why tertiary alcohol is so useful, right? I think in organic reactions, you'll understand why they use tertiary alcohol instead of the primary one and the secondary one. So a quick recap. So under alcohol, you should know your general formula. They might ask you what's the general formula of this alcohol or structure. Then what's the functional group? They might ask you this. So it's a hydroxyl group. The suffix is all. To identify one, the C atom is bonded to OH. That's how you see that it's an alcohol. Then we have types of alcohol. The first one is primary alcohol, which the C atom bonded to OH is bonded to one C atom. Then the secondary alcohol, the C atom bonded to OH is in between two carbons. Then for tertiary alcohol, the C atom bonded to OH is in between three C atoms. I'll try and do a separate section where I show you how to do functional isomers, positional isomers, or isomers as a whole. But now just know that aldehyde and ketone are isomers. So what's the general formula this side? So the general formula of aldehyde is C2CnH2NO. Similar for ketone, CnH2NO. Then what's the functional group this side? So the functional group here is formyl. Then the functional group this side is carbonyl, yeah, carbonyl group. Then the suffix, it's al. Then the suffix this side is 1. How do we identify an aldehyde? So something like that. It has a double bond of O in the C atom at the first or the last carbon, right? So this double bond can only be in the first or last C atom. That's how you differentiate between an aldehyde and a ketone. Then for ketone, this is how we identify one, double bond O. So the double bond, this part should be in the second between the second and the second last carbon in your chain. Don't confuse that, right? Then yeah, that's it. Then let's see how we can name one, right? So I'll start with aldehyde. Let's say we have this 1, 2, 3. Then for this one, the position it's not that the position is not necessary, or the position is not important, because it's always in the first or the last carbon. Then to name one, we'd say how many carbons do we have? 4, and 4 is butane. Then it's in what position? It's in position 1, but the position doesn't matter. Then what's the suffix of aldehyde? It's al. So in simplest term, it's going to be butanal, right? So if we had a side chain, then you do the side chain. So let me just do an example where we have a side chain, because I might assume that we all know, right? But we actually don't. The first thing that we do, we identify the Lorentz chain, identify our homologous series or our functional group. You see that we're dealing with aldehyde, and it's in position 1 or the last carbon. Then Outside of the longest chain, we have a side chain. So let's do our numbering system. So it's going to be 1, 2, 3, 4. 1, 2, 3, 4. Then we choose the smallest number, right? Between 4 and 1, the smallest is 1. So we'll disregard the forward numbering system. Then when following our naming convention, start with position of the side chain, prefix, position of the longest chain, suffix. So what's our position for the side chain? It's in position 3. 3. How many carbons there? It's 1, so it's methyl. Then what's the prefix? The number of carbons is 4, then it's going to be ketone. It's in position 1. Then suffix is al, so it's going to be 3-methyl butanol 1-al, or 3-methyl butanol. Then for ketone, it will be a double bond can only be on the second or the second last carbon, right? In between the second and this up until the second last carbon. So we identify the longest chain, we identify our homologous series. You can see that we have a ketone. Then we do our numbering. So it's 1, 2, 3, 4. 1, 2, 3, 4. Then we choose the smallest one. So in the forward order, you can see that the double bond is in position 2. In the reverse order, in the forward order, the double bond is in position 3. In the reverse order, the double bond is in position 2. So we'll choose this order. You can erase that one. Then let's name, right? How many carbons do we have? For now that we don't have any side chain, we just proceed to the prefix. How many carbons do we have? We have 4, so it's going to be butane. So it's in position what? The double bond is in position 2, so I'll say 2. Then what's the suffix of ketone? Is 1. Then let's do our last example. When we have a side chain, 1, 2, 3, 4, 5. I want 1 here. So we first identify the longest chain. Let's first identify our homologous series. Then that's our homologous series. Then when identifying the longest chain, we'll count closest to that. So it's going to be 1, 2, 3, 4. Okay, let's check for a different one. So it's going to be 1, 2, 3, 4, 5. Then let's check for a different one. Then it's going to be 1, 2, 3, 4, 5. So we can see we have two with the same number of carbons, which is 5 and 5, right? Which is the yellow one and the black one. Then we can choose any order in those two. So I'll stick to that one. That's our longest chain. Then everything outside of that is a side chain. This is our homologous series, so don't count it as a side chain. Then we do our numbering system. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then which numbering system are we going to choose in the forward and the reverse one? Let's check the position of the double bond. It's in position 4 for the forward and in position 2 for the reverse. So we'll stick to the smallest number and stick to the reverse process. Then let's name. So our naming convention says position of the side chain, prefix, position of the longest chain, suffix. The next step, you can see that we have two side chains, right? And if they are the same or they have the same number of carbons, we use di. So di means 2, right? So the first one, it's in position 3. You can say comma. The second one is in position 4. Since it's the same number of carbons, we'll say di. It's 1 carbon, so it's ethyl. Then what's the prefix of the longest chain? It's 5 carbons, so it's going to be pentan. Then what's the position of the double bond? It's 2. What's the suffix? Since we're dealing with ketone, it's going to be 1. So it's going to be 3,4 dimethyl pentan 2 1. And for now, we'll end here, right? So just for recap, we did aldehyde and ketone. The general formula is the same, but the functional group is different. For aldehyde is formyl, then for ketone is carbonyl. Then the suffix is al for aldehyde, and the suffix for ketone is 1. And this is how you identify 1 for aldehyde, and this is how you identify 1 for ketone. Then I did a few examples for aldehyde, also did few examples for ketone. So yeah, the rest we are remaining with carboxylic acid. Then ester will do it in a different section where we are now doing organic reactions. I feel like it's better that way. For now, bye.